Welcome to this lesson about Reg Ag in practice, low-till protected crop production. Typically, protected crop production is one of the most intense production areas within vegetable production, where it is no exception that soils need to be exchanged after just several growing seasons due to salination, continuous cropping, soil acidification, nutrient accumulation, compaction, and chemical residue. Since the infrastructure costs are much higher for protected crops, flipping beds, the process of transitioning from one crop to the next, is often sped up by intensive and frequent tilling. In smaller scale vegetable farming, as well as for all crops grown under glass or plastic cover, maximizing living roots and soil coverage should be an integral part of production to help rebalance soil. To address this issue, we at Schloss Tempelhof Farm have developed a simple low-till and maximal cover cropping system. The system can be broken up into the following steps. The first step is maximizing soil stabilization. The second step is minimal soil disturbance. And the third step is keeping the ground covered. Let's look at maximizing soil stabilization using living roots. Soil bioengineering is the term that is used for the process of using plants and their resources for stabilizing soil. The strength of the roots is used to stabilize and increase the strength of the natural and man-made soil. In the Schloss Tempelhof farm, in the fall, once the summer crops, such as tomatoes, peppers, eggplants, chilies, or cucumbers, have been fully harvested, the above ground plant material is cut off and placed on our compost pile. So they're removed out of the house and put on the compost pile. The roots are initially left in the ground to help maintain structure and feed our soil food web. In the fall, once the summer crops such as tomato, pepper, eggplant, chili, or cucumber have been fully harvested, the above ground plants are cut off and placed on our compost pile. The roots are left in the ground to help maintain structure and feed our soil food web. Even dead roots can play an important role in releasing metabolites that help feed organisms in the rhizosphere. With minimal soil disturbance, just taking out the above ground plant matter, we then are able to transition from our summer crop of, say, a tomato to a diversity of winter hardy salad greens. In our climate, in unheated hoop houses, the crops that we can grow in the winter are quite limited. We plant spinach, baby leaf mixtures, bok choy, purslane, lamb's lettuce, chard, and parsley. We plant our winter cover crops very densely around the summer crop roots, making sure to maximize our soil stabilization via living and dead roots, thus increasing the soil organic matter and ultimately building soil. Direct planting, or low-till. As we have learned from previous lectures, the practice of tilling is the leading cause of soil erosion and topsoil loss. In an article, Soil Erosion and Agricultural Sustainability, a review from data drawn from a global compilation of studies, the author concludes at the end that overall, quote, no-till agriculture produces erosion rates much closer to soil production rates and therefore could provide a foundation for sustainable agriculture. End quote. According to a statement from the Natural Resource Conservation Service and the United States Department of Agriculture, quote, tilling the soil is the equivalent of an earthquake, hurricane, tornado, and forest fire occurring simultaneously to the world of the soil organisms. Stated simply, tillage is bad for the soil, end quote. Many studies have shown that tilling is a downward spiral, leading to erosion, imbalanced and unstable soils. For that reason, no-till practice holds a great potential for regenerative agriculture production. As written on the Regeneration International website, quote, no-till practices allow the soil structure to stay intact and also protect the soil by leaving crop residue on the soil surface. Improved soil structure and soil cover increases the soil's ability to absorb and infiltrate water, which in turn reduces soil erosion and runoff and prevents pollution from entering nearby water sources. No-till practices also slow evaporation, which not only means better absorption of rainwater, but it also increases irrigation efficiency, ultimately leading to higher yields, especially during hot and dry weather. Soil microorganisms, fungi, and bacteria, crucial to soil health, also benefit from no-till practices. When soil is left undisturbed, beneficial soil organisms can establish their communities and feed off of the soil's organic matter. A healthy soil biome is important for nutrient cycling and suppressing plant diseases. As soil organic matter improves, so does the soil's internal structure, increasing the soil's capacity to grow more nutrient-dense crops." End quote. At Schloss Tempelhof, our goal is to transition from one crop to the next with minimal soil disturbance. During the winter months, we harvest our cut winter crops, such as spinach, 2 to 4 times. In the spring, when the new summer crops are ready to be planted, which in our climate happens around the end of April or the beginning of May, rather than tilling the crop, the winter crop, into the soil, thus disturbing the soil and speeding up the mineralization process, we harvest our final winter crops one last time. Then, using a spade, we disturb the soil in only the confined space necessary to directly plant our summer crops into the existing living crop or crop residue. During the first weeks of transplanting the summer crops, such as tomatoes, they are still small and don't require the entire bed space. So direct planting ensures maximal soil coverage as the winter cover crop roots remain active in feeding our soil food web until the summer cover crops take over with their own extensive root systems. We then follow that up by laying a nice layer of mulch to keep the ground covered past the winter cover crop roots. The minimal necessary intervention. As we have learned from the previous lessons, soil structure and microbial life are not in a stagnant state, but rather an evolving and changing process. For this reason, we repeatedly need to ask ourselves, what is the minimal necessary intervention needed for this soil at this time of the year? During the first years of farming of our land, we required many more inputs in the form of compost, aeration, fertilization, as all of the following years. The more often the regenerative principles of increasing the number of living roots, keeping the soil covered, minimizing disturbance, and increasing diversity are implemented, the healthier the soils become and the less inputs are needed. As good soil structure is built up and humus levels increase, our work as farmers becomes easier and less intervention is necessary. During the start of our minimal till system, we still used a broad fork to aerate all of our soil beds prior to planting the summer crop. To jumpstart our soil microbiome, we also spread a layer of 5 to 8 centimeters of compost before planting our main summer crops. In the first years, we used pasture grass mulch material, which has a relatively high carbon to nitrogen ratio and required a lot of additional fertilizer to ensure sufficient plant available nutrients. We previously added this in the form of sheep wool pellets into each planting hole at a rate of about 75 to 150 kilograms of nitrogen per hectare for all of our summer crops. After 5 years of these more intensive practices of aeration, compost, and mulch, our soil organic matter levels of up to a depth of 30 centimeters have increased from about the original 2% to over 6.5%. When interpreting these values, we have to consider the amount of organic matter that is being brought into the system, of course. But in our low-till system, we are not mixing soil deeper than just a few centimeters. So it's clear that the soil biology is actively fixing organic matter into a depth of up to 30 centimeters, where the soil samples are being taken. Another form of evidence that no-till systems are beneficial for soil health can be seen using the scores of the Dr. Andrea Best soil test. In 2021, The soils in our protected culture received a very high score of 93 out of 100 possible points using such a test. This soil analysis was developed to provide practitioners with a scientific method that they can complete by themselves for assessing soil structure that provides an evaluation specific to soil type and horizon. For a full description of the analysis, a full description of the Dr. Andrea Best soil test and analysis can be found in the additional resource section. Given our current soil structure, our soils no longer need the same amount of intervention as in the first years. Now, 8 years into production, we plant our summer crops into the previous crop without aeration, additional fertilizer, or larger compost inputs. Keeping the ground covered with silage transfer mulch is the final step. To continue our example from before, the final step after transplanting our summer crop, such as a tomato, directly into the living winter salad crop is to wait for temperatures to rise and then bring out a silage mulch cover. As we have learned from the previous section on mulch, mulch insulates the ground, keeping extreme temperatures out, which is desirable in the hot summer months, but it also can insulate cold temperatures in the soil. To avoid insulating cold in our ground in the spring, we let our winter crops and summer crops grow together without cover for about 3 to 4 weeks. Ideally, soil temperatures should be at about 15 degrees Celsius or higher. This can be supported by keeping the ventilation closed as much as possible for about 1 to 2 weeks before mulching. Waiting longer than 3 to 4 weeks, however, is problematic, since at this point we want to avoid competition between the living winter crop, which at this point often is beginning to flower and go into seed, and the oncoming growing summer crop. As soon as the summer crop requires more space, light, and nutrients, and the ground temperatures have risen, the silage mulch helps suppress the competition of unwanted plants and weeds while keeping the ground covered and moist. In this case, suppressing then the winter cover crop that is still remaining on the same bed. We want the ground to stay moist, but we also want to avoid plant stem issues. So for this reason, we often leave a small ring directly around the stems where mulch does not come in contact with. In our indoor mulch production, we have transitioned from using pasture grass as a mulch source to silage mulch. Firstly, through the fermentation process in silage, weed seeds become unviable. This is a huge advantage, since dealing with grass seeds can be a big challenge with freshly cut pasture grasses, particularly when combined in a low to no-till system. Since silage is harvested in fall prior to usage, we are much more flexible with our timing. We don't need to risk harvesting our pasture too early in the spring or driving on wet fields. The final large benefit we see from using silage mulch versus pasture grass is that through the fermentation process, the nutrients are pre-digested and thus quicker for the plant to uptake. This also translates into needing a far smaller amount of material to be carted in. Rather than the 20 to 25 centimeters of pasture grass mulch that is needed, with silage grass, we are only applying 10 to 12 centimeters. Things that need to be considered when mulching with silage are, on the one hand, leaf burning issues due to the gas emission from silage. And this is a very important point. To avoid burning, we pre-ventilate the material, so the silage material, and we spread it out. We spread our silage outside of the greenhouse for 3 to 4 days so that it can gas out. And then once we carry the mulch material in, we're also making sure to ventilate as often as possible. Also, perennial weeds can become a problem, even under silage mulch. So silage mulch, as other mulch forms, is effective in annual weed suppression. Perennial weeds can also be a problem even under silage mulch. So annual weeds are no issue. They're easily suppressed, but perennial weeds, like in other mulch systems, need to be taken into account. There is a possible risk of mice and our snail infestation. Oftentimes mulch provides a nice habitat for animals. So this needs to be also thought about prior to implementing the system on a large scale. Depending on the mulch material, nitrogen blockage is important to take into account because subsequent fertilization in mulch systems is quite difficult. It can only be done then through liquid fertilization. Delayed mineralization due to reduced soil temperature. We talked about that already, but if I'm bringing in my mulch material too soon into my protected culture, I do risk potentially insulating the cold into my soil. So which can then decrease mineralization rates, which I am not wanting in the wet, cold springs. The final one is if we're using mulch material that is too rich in nitrogen and decomposes too quickly, then we often have a lot of, either we need to re-mulch, which is very time consuming, or we are needing to cultivate in a mulched crop, which is also kind of defeats the purpose of weed suppression through mulch. So those are a few points that are important to think about before implementing such a system. Also, mulch nutrient contents should be really taken into account when doing a fertilization calculation. Studies show that between 20 to 40% of nitrogen becomes available to the plant in the short term. Given the fertilization input of silage transfer mulch, we do not add any other nitrogen fertilizer for our crops. An estimation of nitrogen available for the tomato crop in our system from a grass clover silage is about 250 kilograms of N per hectare. Minimal soil disturbance. After the summer crop is fully harvested, we cut the crop at the stem so that the roots stay in the soil and the above ground material is taken out of the house and put on the compost heap. The final step is to rake the minimal layer of undecomposed mulch into the pathways if necessary, and then plant the winter salad directly on the beds. Using this no-till crop rotation, we can keep our soils covered with either living roots or a combination of living roots and transfer mulch over the entire year. And here on this picture, we see that throughout all of the months shown, there is a cover on our ground, either through the winter crop, then the summer crop, and then the summer crop with the combination of mulch. So let's summarize. In the demanding cultivation under protected culture, it is all the more important to incorporate regenerative principles. In this case, we have maximized our soil stabilization using living roots. We have minimal soil disturbance through direct planting, and we have kept the ground covered as often as possible. As can be seen on this image that provides an overview of the entire production year, there are ways to grow productively while continuously ensuring maximal soil coverage and minimal soil disturbance. Other important tools for regenerative vegetable production, which we didn't have time for in this lecture, are available in the additional resource section. These tools include intercropping, the use of compost, as well as compost tea as a foliar spray. Thank you for watching this lesson.